So now that I've made some really basic aesthetic decisions in this project, I want to start to focus on the mechanics. Now, the core concept of this project is that we want the user to be able to control this rocket. And so I'm going to select the rocket. I'm going to focus on building a couple of different state machines. And the first thing I'm going to do is I'm going to build a real simple state machine that allows for a thrust mechanic or pushing the object up along the y-axis when we press a given key. So what I'm going to do is I'm going to add an FSM, or a state machine, and I'm going to call this FSM rocket thrust. Now I'm going to have multiple machines on this object, so it's very important that we start naming our state machines accordingly. I also want to get in the habit of making sure at this point that I'm naming all of my states appropriately, and I'm just going to create an idle state. The idle state is going to wire over to another state that is thrusting. And so I want to build a little action here that kind of ties these two things together. And so I'll just jump over to my actions, and I'm listening for some input, and I'll use the mouse button in this case. But again, the design is really up to you as far as how you want this input to work. I'm going to listen for a get mouse button down. And I'm listening for a left click, and when that happens, I'm going to create an event that says thrust. Now while I'm here, I'm also going to create a reset event because I want to send from idle over to thrusting, and then I want to reset it back. So I have just two different events here. I'm going to attach the thrust send event on the idle state when the mouse button is down, and I'll add this as a transition and wire that over to thrusting. So right now, if I press the mouse button, I should pass this over to thrusting. And I'm pretty convinced that's going to work. I do recommend that you test these things as you go because it'll be easier to kind of squash bugs, but I'm pretty confident that's going to work. I'm now going to listen for a mouse button up on the thrusting phase. I'm listening for the left mouse up, and when it does get a mouse up, I want to add the reset action, and I'll wire that back to idle. So again, the basic mechanic here is that in the idle state, I'm listening for the mouse button to go down, left mouse button. When it does, it passes it through this thrust event over to thrusting, and thrusting is listening for a mouse up. When that happens, it resets. And so the idea is that when the mouse is up, we're in the idle state. When I press the mouse, we're in the thrusting state. When I release the mouse, we're back in the idle state. So now at this point, we can go to the thrusting state and do a real simple physics command. So I'm looking for physics. And from physics, we're going to add force. I'll double click. Now the force that we're going to add is using the owner game object. That's good. I want to send this along the y-axis, and so I'm not sure what the value is here that I want to use. I'll start off with 30. And I want to do this every frame, but rather than using the world space, the default mode is world, I'm going to change this to self. And the difference here is that we'll see this really dramatic results once we start rotating the rocket. But for now, whether I have this set to world or self, it should work just the same because we're not changing the direction it's pointing. But now at this point, when I press the mouse button, I have this basic thrust command. Now I'm thrusting, I'm idling, and when I release the mouse, it takes a while for this thing to fall back to the ground. And I can really kind of balance this user input. If I don't like how long it takes to fall, there's a couple of things that I can do. I could play with, in the rigid body of the rocket, we could play with mass and drag. If I increase the mass, it'll be a little bit less responsive to the thrust. If I increase the drag, that will cause it to slow down much quicker. I don't have to do both of these, but you can see it's much harder to kind of push that rocket up. And my rocket is starting to drift backwards, and I've landed, and that was, that's okay. But you can see when I stop, it starts to fall much quicker. So I'm probably going to just set this back for the demo back to 1 and maybe 0.2 for the drag. Again, I can play with those values to really get a sense of what's going on here. Now, I could also, if I wanted to, restrict some of the motion that could happen. Now, my rocket right now could rotate along the x-axis. And this is not something that I want, because if I bump into an object, it might cause my rocket to point away from the camera or towards the camera. That's an X rotation. So what I can do is in the rigid body tag, I'll go into the constraints and I'll freeze the rotation of X. Okay. Now I could, if I want to, I could also freeze the Y rotation. So in other words, maybe I don't want the rocket to spin on its own axis. I'll undo that and set the Y back to 0 in terms of the rotation. Or maybe I do, maybe it's an effect that I want to happen, but I'm going to have a lot more control over it if I restrict that Y rotation as well. Now I want to leave Z unrestricted, because in a moment what we'll do is we'll be able to control the Z rotation, or change the direction that the rocket is pointing relative to the camera, and apply thrust and be able to control the rocket through rotating and thrusting. Okay, so right now I have this simple state that's causing the thrust to apply, and that's working just fine. But what I want to do now is I want to build a separate state machine, and I can do that by clicking on this little drop-down menu here that says the name of the current state machine we're working on, and I can add an FSM. So now I have two state machines. This state machine, I'll call it FSM rocket rotation. And in the state, there's a couple different ways that I could do this, and I'll take the simplest approach. And that is, I'll go to actions and I'll listen for some user input. So I'm looking for my input. I could do simply a get axis, and then I could label the axis that I want to listen for. In fact, I'll probably do it that way. Alternatively, I could do a get axis vector where it's listening for, in fact, let me add this for a moment here and take a closer look at this. If we're doing a get axis vector, we're listening to both the horizontal axis and the vertical axis. Now, we won't really use the vertical axis unless we wanted that to control our thrust, but we've already built a mechanism for that. So really all we need is this horizontal axis, and I'll copy that while I have it selected. It'll save me a few keystrokes. What I'm going to do is I'm going to do a get axis, okay? And I'm going to get rid of the get axis vector. The axis name that I'm listening for, I'll paste horizontal, capital H, horizontal, in that field, and this will satisfy the left-right control. So the horizontal axis is listening for either the arrow keys or the A and D keys, and that's really what I want. So I don't really need to use this get axis vector. It's just kind of pre-configured to listen for both horizontal and vertical. So I'll click on that and I will remove that action. I'm listening for the horizontal user input, and what I want to do is I want to store that in a variable. And this variable is probably a float. Yep, I can see when I roll my mouse over it. The parameter it's looking for is a float. So what I'll do is I'll go to my variables and I'll call this rocket rotation, and I'll create a float based on that title. I'll go back to my state and I'll store the user input in that rocket rotation float. So now when I hit the play button, it's not actually going to rotate the thing yet, but if I hold down the A key, you can see that my rocket rotation goes to -1. If I rotate my the D key, it goes to +1. Now I have a feeling, if I hold down the right key, I'm just going to test something here, and I rotate in the positive Z, we're probably going to rotate the wrong way. In fact, so right now when I go into the positive Z, positive rotation, it's actually leaning back towards the left relative to the camera. I'll undo that, and that is not what we want. So in other words, if I'm looking at this state, and once I build the rotation command, the keys are going to be reversed, but I'll show you how to fix that in just a moment. So let me handle the rotation here. What I'm going to do is I'm going to go and look for the transform category, and I'm looking for a rotate. I'll double click and add a rotate, and what we're going to do is we're going to rotate the object along its Z angle. Okay, we want it to rotate along the blue axis. Okay, and we want it to rotate according to the rocket rotation value. Okay, We'll do this every frame. That's fine. I'll let everything else default. I am doing this in its self space, although in this case, it doesn't really matter whether it's the world or the self space, because the rocket's z-axis is always going to line up with the world z-axis in this case. Okay. I'm going to hit the play button. So now what happens is when I hold down the thrust key, I can float in the air. But when I hold down the left or right keys and I get my rocket to change its direction, I have a little bit of a glitch in that when I'm going to press the D key right now, and I'm actually rotating to the left, which is not at all what I want. I want the opposite to happen. And the reason that's happening is because the user input that's mapping left and right is using a positive value for the right and a negative value for the left. And so we're getting the opposite results that we want. So what we can do is we can go into the multiplier. The easiest fix here is in the get axis. If we take out the multiplier and we put a negative in front of the 1, what we get is we get the inverse of our rotation. And the reason that is because if we take a negative number, and this is a multiplier, so if we multiply it against our user input, if we take a negative number and we multiply it against a negative number, what do we get? That's right, we get a positive number. And if we take a negative number and we multiply it against a positive number, the result is that we get a negative number, effectively inverting the results of our rotation. So when I hit the play button now and I press the thrust button, now when I use my D key, it actually points off to the right. I'll use my A key and it points off to the left, and so now I have this basic control system here where I can fly my rocket around. Now, I'm going to land my rocket, and I'm pretty satisfied with that. I am going to continue to tweak the user input because I do think that there's going to be a benefit to having the rocket. Right now it's rotated back to the left position, and really what I want it to do is I want it to autocorrect and start moving its way back to its upright position when we let off the keys, and I'll be able to do that with a couple of simple commands, but we'll do that in the next presentation. So get your rocket active, up and running, be able to control the rocket, and we'll press forward in the next presentation.